Hello everyone, welcome to my class again. Today we are going to learn intelligence control. Why must be intelligent control? The last time we have learned PID control, knowing how to tuning PID and also about its response. But PID control still has a limitation. Some system is not enough controlled by PID. Today I'm going to introduce another control, which is the intelligent system to you. So, what is the weak point of PID control? We are going to see it together. I already prepared a Simulink for you. We're going to use the same transfer function that we have learned in the previous class. And all k constants are already calculated. Okay. Um, I will set this value back. Okay, this is the system that I taught you to tune it. According to synchronical theory, as I can remember, and it will give us this response as you can see in the graph. It has overshoot around 20% or used a least overshoot formula to calculate k constant. So we will have this response. Okay, let's see what is the weakness of PID control and how it is. PID will be fixed or k constant to make the system to provide a response that we want it to be. Okay, I will describe for more information about system. Suppose that this is transfer function, which is robot arm. So we will control the position of the robot by motor to move the arm in the correct angle. Suppose that we add input as unit step function and change the position from 0 degree to 1 degree rapidly. So we will have the response. And this is the response that we have, which we tune it to be look like unit step function as most as it can be. This is our set point. When we already define it, the system will measure the value that will send it back as a feedback and compare it with input and working through our PID control to transfer function. Transfer function is our system. Again, transfer function is our system. If it's a robot arm, transfer function will be a motor, the length of robot arm and weight of robot arm combined together as transfer function. When we use output from PD control transfer function, we will have the response that system provide, and the system will send the feedback back to compare with input again over and over. This is the system control. Okay, the weakness of PID will be like if the system had been changed, like if the weight of the robot had been raised, or have some resistant force, or move in a different angle vertically. It will be like if robot move upward or downward, the gravity will affect its movement, which make the robot move in a different velocity. If you cannot imagine that, I will show you my experience video. This is the system that we already set the control part, and that make it move up and down smoothly. We use intelligent control. Okay, something like this. Okay, if the weight of the robot had been changed, the angle of movement had been changed from 0 to 90 and from 90 to 0, coefficient value, which are the number in transfer function, will also change. It won't be the same. If I do some experiment by change this coefficient value to show you, okay, I will try and I want you to see the response, how it will be if we use PD control. I will change to 56, change to 30. See, the response had been changed. What's happened if it's a robot? The robot will oscillate severely, which is not okay. But I want you to notice that steady state error still be the same. It still be the same. PID can decrease error and make it zero, but if system environment had been changed, response will also change. It depends on works that you are serious about response or error. If we talk about temperature, this response may be not important. We may be not worry about this oscillation, right? Finally, we only want a constant temperature and can hold that temperature in many environments. PD can use if we only want something like that. For example, air condition, which work in the same environment, same room, no change, no addition of heat. PD can cope with that. If the weather is hotter than usual, the response may be changed, but finally, steady state still be the same. But if it's a robot, it's gonna be in trouble when its movement is like this. Can you imagine that? So PD control that we learn is maybe not enough. We maybe need to learn the system that is more intelligent control. So today I want to introduce you one of intelligent system. It's named Fuzzy Logic. It's one kind of AI, like an easy one, an easy AI. So how can we replace PID with fuzzy logic and how it works? That's what we are going to learn today. I will teach you its theory and its algorithm and what its algorithm and how it works. Okay, let's see. But before we go to intelligent control, we have to know intelligent system first. Intelligent system is a system that will create a universal approximator. Again, it is a system that will create universal approximator. As you can see here in the picture, it's like we will have a desired function. If you compare to PID, it is a unit step function. We add unit step in and we want a unit step out as an output. But if you want output that look like this surface of x, fx1 and fx2, we will use these two principles. The first one, input separation, which means we will separate it to many groups. Okay, and then we will move to a mapping process. In the second, we will map x1 and x2 out into this function. Mapping is like, if compared to PID, we add input into a transfer function, and that's what we have. A good mapping is going to happen or not is depend on system that we set, that we design. Fuzzy logic has a method of calculation that is not usual. I mean, it's, it's not a formula or it's not an equation. Fuzzy logic is a system that mimic a logic of human. The easiest human logic is if and then. For example, if the first if the first reason and the second reason and the third reason, then we will have a result. It's something like this. Fuzzy logic will copy human logic. As we as a human have created many kinds of intelligent system like neural network, and neural network is also mimic a structure of neuron cell. Deep learning will have these many layers of neuron cell structure. So fuzzy logic is one kind of intelligent system that mimic a logic of human. Next, we're going to see the structure of intelligent system or this fuzzy logic to see what it has. Let's see. Okay, let me see a last view page to make you see a clear picture first. Ah, this is the main structure of fuzzy logic, a process, a basic structure of it. As you can see, it seems like PID, right? It has loop. Most of intelligent system always be a closed loop. First, add input in into a closed loop. It may be x1, x2, or x3. And then it will go to a falsification process. A falsification process is a grouping of input. I mean that which group that input should be in. I will describe for more detail later about how can we choose a group for input. Okay, let's review it again. Add input in, and then grouping it, and then throw into an inference process. I will describe for more later about how it works. It will work under rule-based and database, relatively. When inference process is finished, and then it will move to the falsification process. The falsificate is a calculation of a value to find output. We can find that how output it will be when we add this input in. It seems like PID, right? But this rule-based and inference will not be a formula of PID. Okay, let's get into it for more detail about this. Beginning with falsification, a grouping process. Fuzzy logic, in the other hand, it has another name, means a vague logic. Why is vague? For example, if we talk about temperature, when it comes to computer logic, it would be just hot or cold, just two of these choices. A logic would be only 1 or 0, but it's not for fuzzy logic. Why? We, as a human, always had a vague logic. Suppose that at 12 degrees, somebody may say, it's fine, it's cool. But someone may say it's too cold. Someone says it's too hot. So, this is ambiguity of human. Because individually, we are all define hot or cold differently. As a picture shown here, If it's computer, it would say just true or false. But if it's a human, it would has this ambiguity shown here in a gray color. It's not defined black or white. So if we want to group a value of temperature, that is hot or cold, it would has a value of member or membership value. Don't be confused. Let's see it together. Ah, this is computer logic. A married couple has 0%. I mean, it has a membership value 0. An unmarried couple have membership value 1. So you can see that the set of married couple will separate from the set of unmarried couple very clearly. But when we add some human logic, it may have something overlap, but it's not shown here in this case. We will going to talk about it later for more example. Usually, a value of membership will be in between 0 to 1. If it's 1, it means it has a higher membership value. If it's between 0 to 1, it means that it still has some membership. For example, temperature at 22 degrees in a group of a cool group. For someone, it may has a value of membership at 100%, which is 1, or for someone, it has 50% or 0.5. In okay, and this is a shape of it. The first one is from computer. It had a membership value at 1 in a set of fat people. It means that at 70 to 100 kilograms, computer will determine that they are fat, and that's it. But for fuzzy logic, which mimic from a human logic, someone says 70 kilogram is not that fat. A membership value will be low. When number of weight go higher, they may say, okay, this is mean fat. So membership value we had the highest value. But when it still go higher than the middle value, you can see that the membership value will go lower because it may change to another group which is a very fat group. And it can also has a group like a very fat group. This is a discrete membership function. If you write a coding, it's gonna look like this. And this is continuous membership function. I forget to tell you that this kind of membership function is a linear membership function. And actually, membership function may not only be just linear. There are a lot of kind of membership function. There can be another kind of membership such as like this, a curve V1. I will give you some example. Suppose that we talk about hot and cold again. In the middle group is the medium temperature. If temperature is lower than this, the membership value will be decreased rapidly, like this curve. And it also overlaps with a low temperature group. Some temperature is in two group, which is in both low and medium group. Some temperature is in medium and hot group, and also high and very high. Group to group always overlap to each other. This is ambiguity of creating fuzzy set. So this is a group. This is a grouping by add input in here and determine each input that which group they should be in. If it's a robot, okay, let me find uh, a video. Okay, uh, suppose that we set a set point at 90 degree while the robot is at 30 degrees. From 30 degrees to 90 degrees, input of the system is error, like this one. From 30 degrees to 90 degrees. When it's already at 30 degrees, the error would be around 30, right? The error will be lower. I can define it in a low group. When it reach in the another degree, like it reach at 85 degrees, the error is just 2 degrees. I can say it may be in a very low group. But if it reach at 98.2 degrees, it may be in an extremely low group and overlap with very low group maybe. This is how vague it is, that which group it should be in. This is how we put each of input in a group before mapping. So when we talk about mapping, a mapping will use inference and rule-based. For a grouping process, what it has mainly, we have to set parameter of group, how many group and what they are, like high, medium, or low. And then choose a proper membership function for those input. So the question is, how can we choose a right membership function? Usually, most of systems in this world always wanted to be a linearity. So a triangular function is the most famous one because systems are wanted to be a linearity. But if some system use this linearity function, then the result is not what we want. It has to be changed. It has to be changed membership function to another function. We have to do an experiment, or we have to do a research or do a survey first. By being given value or score of membership function and plot it into a graph. It depends on technical process. Okay, this is enough for falsification. So the next chapter or the next video, we are going to talk about how can we analyze the inference and the rule base, and then the falsification. This is enough for today. Thank you for your attention. Bye.